Hi everyone, this is Ranjit and welcome to the second video in the video series where we build a C++ library with all kinds of computational geometry algorithms. So in the last video we created our C++ project and a .NET project which is meant to just connect our C++ project to Rhino in the end to visualize the results and test our algorithm. So in this video, let's make some more progress towards getting everything connected and linked up. So what we want to do is link these two projects together using PInvoke and also get the functions ready, get the functions in the C# project ready to be used from a C# component in Grasshopper. And we will get the whole pipeline working. What I mean by pipeline is being able to call a function in the C# component of Grasshopper, then have that function call a C++ function and get the data back all the way to Rhino and see the results there, right? So when we initialized this project, when we created this project in the last video, it came with this class1.cs file. It's a stupid name for a class, so I'm going to rename it to something else. Well, test is also kind of a stupid name, but once we start writing actual algorithms, we're going to come up with more meaningful names. Today is just a test run to connect everything and make sure everything's working, so I'm just going to name it test.cs. Earlier, before renaming, the name of the file matched the name of the class, so it's suggesting whether I also want to rename the class, which I want to do, so I'm going to click yes. It renamed the class for us, and this class will just have a static method, which is going to do something trivial only for test purposes. So let's just write a static method that returns an integer, right? Let's call it getSquare. So it takes an integer as an input parameter and then returns the square of that integer. So we don't want to write something like, I'm sorry, turn my caps lock on. We don't want to write something like that. That defeats the whole purpose of this test class. We want to pass this integer to our C++ DLL and then have our C++ DLL return the answer to us. So to do that, we need to set some other things up, and until we can do that, I'm just going to add this throw new not implemented exception. I just like adding these to all empty methods so that I don't see this ugly red squiggly line telling me not all code paths return a value. So now let's just switch to our C++ project, right click on it and say add and select class. I'm going to name this class base. In fact, actually I'm not actually going to use a class named base, but I like using this particular interface because it creates both the header file and the source file in one go with the same name. It's just easier. So let's just create that, and it creates an empty class called base for us. We're not going to need that yet, so I'm just going to remove that for now. Okay, so we have this base header file and the base source file. Oh, looks like by default Visual Studio included this precompiled header in our base source file, which we don't want. So let's just remove that, but we're not done yet. Just removing that include statement is not enough. You'll see what I mean. So if I just build right now, I get this exception, unexpected end of file while looking for precompiled header. Did you forget to add #include pch.h? No, Visual Studio, we didn't forget, we removed it deliberately. So to fix that problem, we go into the properties of the C++ project, go into C++, go into the precompiled header section, and here we have a setting called precompiled header, and it's set to use /yu. We want to set it to not using precompiled headers, and make sure you have it set to all configurations here, not just one configuration, because you don't want to use it ever. So I'm going to set it to not using precompiled headers, apply, okay. And now if we build it, it builds without errors. Okay, now for a second, let's go back to our C# project. Let's create another class in C#, and I'm going to call it unsafe. And this class will contain all the declarations of unsafe methods, which are essentially entry points to our C++ DLL, right? So this is, yeah, let's just write a simple method for our test purposes. It's going to be private, static, extern. Well, it can't be private because we will be using it from our test class, so it has to be internal. In fact, let's make the whole unsafe class internal, because we don't have any reason to make it public yet. So extern, which just means it's going to be external. Let's call the function test underscore get square. It takes an integer parameter. We forgot the return type. It returns an integer as well. So we're going to have to tell Visual Studio where to find this external method. So we are going to add this attribute DLL import. Okay, to use that, I have to add a using directive at the top here, using system.runtime.interrupt services. And now it recognizes DLL import. And we have to supply the name for this DLL. I could just type the name here, but I'm going to have a lot of these static extern methods in this class. As we start implementing algorithms, we're going to have a lot of these methods, and I don't want to type a literal string every time. So I'm just going to create a private constant string DLL name, and by default the DLL that we built in our C++ project is same as the name of the project itself. So it's going to be called GeomAlgoLib, not ALOGLib. So that was the name of the DLL. Let's just pass it as a parameter here. And the second parameter we want to pass is calling convention, and it's an enum. We're going to set it to calling convention dot C declaration. These two lines are telling the .NET compiler that, okay, at runtime, there's going to be a function available with this name and with this signature. I'm not going to write the logic for this function yet. I'm just making a promise to the .NET compiler that it will be available at runtime, and it's supposed to look for this function in this DLL, right? So it's just a promise that we're making to the .NET compiler, and we have to make sure that this function exists at runtime. If we don't, it's going to throw an exception. It will believe us at compile time, and it will just it will build without errors, but then at runtime it will throw an exception. So now let's switch back to our base.h header file in the C++ project, and let's actually declare this function that we're going to use in our C# code. So our function returns an integer, and we have to have the same name for the function, test get square. So that's our function. That's just the declaration. Let me just make sure that the name is the same. So we called it test get square. So that's fine. But if we just declare this function like this, it's not going to be accessible to our C# DLL. It's not going to be exposed to our C# code. So to do that, we have to write extern C declaration spec DLL export. What this means is that this is a C style function because, we told our C# code that the function is going to have C style declaration. We have to match that. This is a C style function that will be exported from this DLL to be used by something else as an entry point. Okay, so that would work, but we're going to use this phrase a lot for every function that we actually expose as an entry point. We're going to use that, so we might as well define it as a macro to make our lives a little bit easier. So I'm going to just define a macro PInvoke, and I'm going to use that here. And now this function is declared, but we have to write the definition for this function. So I'm going to hold down Control and press dot, the period key, and that brings up this quick action menu, and I can just select create definition for test get square in base.cpp, and it creates this, I don't know what that is. It created whatever, but let's just write the logic for this function, which is very simple. We just have to return the square of the input parameter, right? So that function is defined. Let's just build everything and see it builds. So everything is building correctly. Now let's switch back to our test.cs, and let's just use the unsafe function. So we will say unsafe dot return unsafe dot test get square and pass our integer. So in theory, this function will be called from Grasshopper, which in turn will call this function and pass the input parameter. And the logic of this function is not declared in C# itself. We just promised C# compiler that it's going to find this function in this DLL at runtime. And hopefully it's going to find the function that which we added in C# and be able to actually run it. Okay, so before we can actually run our code from within Rhino, it's also very useful to be able to debug our code from within Rhino so that we can see what's going on. So to do that, we are going to have to do a couple things. We have to go into the properties of our Rhino interface project and go into the debug section, and under start action, select the start external program option. And here we're going to specify where Rhino is installed. So I'm just going to browse to my Rhino installation path. For me, it's under C program files. So I just selected my Rhino exe, and we're going to have to do one more thing. We're going to have to check this box that says enable native code debugging. So this is what will actually allow us to debug C++ code from within Rhino. So now that's set up, you have to right click on Rhino interface project and set it as startup project. So when you do that, you should see the title of the project should be in bold compared to the other project. So now when you hit F5, that it uses that project settings and starts up Rhino. Okay, so it seems to work. Let's open up Grasshopper. And let's just create a C# component that runs our test function. So it's going to have one parameter, and for the sake of consistency, I'm going to also name that n. It's going to have item access, so let's just leave it as it is. The type of that parameter is going to be an integer. Okay, before we can access our function, we have to add the DLL that we created. So I clicked, okay, let me just repeat what I just did. I right-clicked on the component, manage assemblies, add, and I'm just going to navigate to the target path of our Rhino interface project. So here I navigated to the target location of the target path of our Rhino interface project, and I added the DLL. We only have to add the Rhino interface DLL. We don't have to add the other DLL. It will just be used at runtime. So now we can go into the code. Now that the DLL is added, we should be able to access the namespace and the class that we just created. So if I type Rhino interface dot test, okay, it looks like we have the method get square. It takes an integer, so let's just pass the input parameter and set the result to the output parameter A. Right? No exceptions, good sign. Let's just plug in an integer like 6 into this and see what we get back. So we get back 36, which is what I expected. So now let's actually put a breakpoint in our code and step through the code. And I want to prove to you that we're actually running the C++ code to get this answer back. So I'm going to plug this wire in again to re-trigger the component, and we hit the breakpoint. Because we checked that box that said enable native code debugging, we can hit F11 at this breakpoint and step into the unsafe method. And now we are actually in C++ code. So we're inside base.cpp where we define this function, and now it shows us the correct value 6, and we return n times n. Okay, so now that the pipeline is set up, we're ready to actually start writing our algorithms, which is what we will start in the next video. Well, the first algorithm that I have lined up is the 3D convex hull algorithm, but before that we will start writing some basic structures like to store 3D vectors and basic 3D operations that we are going to be using in our convex hull. So that's what the next video is going to be about. So with the basic pipeline setup with Rhino connected to the C++ library, that essentially concludes this video. Thanks for watching and see you next time. Bye.